Welcome to the second installment of the Men of Modern Mathematics, based on the IBM poster of the same name from 1966. So today's mathematician is Bhaskara. I think it's pronounced, according to the internet, Bhaskara. And as you can see here, he was born in 1114 to 1158. However, the internet, Wikipedia says it's actually 1185. And I believe that because I think that information is more recent and has been researched more. And he's not just from India, but according to the internet, he is from this one. I'm definitely going to screw up the pronunciation. So my apologies to any of my Indian listeners, but he's from a place called Vijayadavidya. And it's also Bhaskara II, because there was somebody named Bhaskara I who was somewhat famous, I guess. So he was called the second. But he was a mathematician, unlike the first, I believe. And he is regarded as the greatest mathematician in medieval India. And he's also the only ancient mathematician immortalized in a monument, or on a monument, I should say. And the monument was created by his grandson to memorialize his accomplishments. His main work, which I won't bother pronouncing the name of, translates into a crown of treatises. And it's divided into four works, one about arithmetic, another one about algebra, one on the math of planets, and the final one on spheres. He looked askance at negative numbers, as it says here on the poster, but he did prove that if you multiply two negatives, you get a positive. He is also famous for solving the equation 61x squared plus 1 equals y squared. And this is a problem that eluded Fermat and many European colleagues centuries later. And the other little tidbit here that's on the poster is that he was also known for providing a one-word proof of the Pythagorean theorem. Even though this proof had already been done by the Chinese earlier, he included it in his book. And the one word was behold. And the proof is actually a picture. So here is the image, as you can see. He's taken a triangle, a right angle triangle with A, B, and C being the hypotenuse, and he has built a square around it, which represents c squared, right? The area of that square is c squared. And then he's basically rearranged the triangles and shapes in the square, right? So the square consists of four triangles that are exactly the same, with the A, B, and C being the sides. And then there's a square that's A minus B. And then he's rearranged it here on the right. And you can see that the area in orange is B squared, and the area in blue is A squared. And that together, because it's made of the same shapes, it must equal c squared. So a pretty nice graphical proof of Pythagorean's theorem, at least for one example. All right, that's it for this week, and I'll try to do these on a weekly basis. I missed a couple of weeks because of the holidays, but have a good week.